So hello and welcome everyone to another video. So today we'll discuss the atmospheric science questions from CUET exam. So we'll start off with 20 questions. So first question is given an example of geophysical disaster. So what is a geophysical disaster? Part I have to understand what is geophysical disaster. So a geophysical disaster is something that occur or produced because of Earth's internal dynamic or because of tectonic activity. So that is one thing. Another thing, remember, in geophysical your disaster, it always includes Earth's material like Earth's mantle material like lithospheric material or soil, rock. This type of material always involved in geophysical disaster. So your volcano, earthquake, tsunami, landslides, they all come under geophysical disaster. So answer will be volcano. Then cyclone, it is a meteorological disaster which occur because of atmospheric condition, because of low pressure. It is also called as atmospheric hazard. Then flood it is because of hydrological disaster. Then come to this avalanche. So landslide and avalanche, both are mass movement, but landslide it is geophysical disaster, but avalanche it is a disaster that is occur because of ice or snow. It is called as your hydrological disaster, or you can say it is can be called as your cryospheric disaster. So because avalanche it involves water, so that's why it come under hydrological. Though it is a mass movement, but it is not a geophysical disaster because it does not include any soil or rock or lithospheric material. So our answer will be volcano here. Then what is the approximate distance between each degree of latitude? So what is latitude? These are lines on the earth that runs from east to west. You can say there are two terms we use to define a precise location on the earth, or latitude, and that is it is called as a latitude and longitude. This is Earth's grid system that used to determine precise location on earth. So latitude that runs from east to west, longitude run from north to south. So from 0 degree latitude and 0 degree longitude we measure distance on the earth surface. So from latitude we measure distance towards north and south. From longitude we measure distance from east and west. So from 0 degree, that is from equator, and 0 degree longitude is called meridian. And each latitude it is placed at 1 degree interval. So if you take the circumference of the median, it will be 42,000. It is 40,000 kilometer, and each interval between the latitude it is 1 degree. So if you take the meridian, it will intersect all the your latitude, which will be 360 degree to 111 kilometer. So approximately each degree is your 111 kilometer approximately. So answer will be here 110 kilometer. Then which of the following greenhouse gases is the fourth most abundant in atmosphere? So what is a greenhouse gases? These are gases present on the atmosphere. They trap the radiation from the earth, or radiated heat from the earth, which increase the temperature within the atmosphere. So greenhouse gases are your water vapor, carbon dioxide, methane, nitrous oxide. So it is written in decreasing order. So water vapor is the most abundant, then carbon dioxide, then methane, then fourth number is your nitrous oxide. So answer will be here nitrous oxide. So if you consider the composition of the atmosphere near the earth's surface, they are classified into two main gases you will find. One is your permanent gases, another is your variable gases. So the permanent gases that are present within the earth's within the atmosphere, their percentage almost remain constant for longer period of time, and they does not change with location and the time. So those are nitrogen, oxygen, argon, neon. So where nitrogen is the most abundant, which is occupies 78% of the total permanent gases. So oxygen is the next, which is approximately 21%. Then variable gases, these changes with time and location, that is water vapor, carbon dioxide, greenhouse gases, CFC. So they changes. So they are called as a variable gases. Another is your dust particle aerosols, what we called. They also helps to produce or form the cloud. So answer will be here nitrous oxide. It is the fourth most abundant greenhouse gases. Then tropical cyclone in the eastern and central North Pacific. So tropical cyclone that occur in between 2 to 5 degree, 2 to 20 degree latitude, you can say 5 to 20 degree, you can say 5 to 20 degree latitude from the on the both north and south side of the equator. They produce in the tropical ocean because of the warming of ocean. When ocean temperature reaches to 26 to 27 degree temperature, they produce a low pressure region where air will rise, and because of Coriolis effect, air produce a rotating effect, what we call cyclone. Then the cyclone produce in the ocean, they are warmer water, so they collect moisture and produce heavy rain, and you can say heavy wind also produce there. They gradually move towards the land where they weakens because of lack of moisture. So these cyclones are called different names in different regions. So hurricanes are called in eastern and central North Pacific. So answer will be hurricanes. Let's see others. That is typhoon in northwestern part of the Pacific, northwestern part of the Pacific. Then Willy Willy is in Australia, and cyclone it is in Indian Ocean. An abnormal warming or weather pattern observed in Pacific Ocean is known as. So in Pacific Ocean, there is a special weather pattern developed. They are called as El Nino or La Nino. So El Nino indicate the warming phase, La Nina indicate the colder phase. So answer will be El Nino. Let's see briefly how El Nino occurs. There are three phases in these regions. One is your neutral phase, one is your El Nino phase, another is La Nina phase. During neutral phase, what happens? There will be stronger trade wind. So this trade wind, they helps to displace the water along the equator, which is called as equatorial currents. You can say this is north equatorial current, this is south equatorial current. They displace water, warm water from these regions. That is during in the region between Ecuador and Peru or the Central South America. They displace water towards the western part. Because of these strong trade winds, water displaced from east to west towards these South Asian part. You can say Australia, then these regions. So these regions, because of arrival of warm water, these regions become warmer. So this is a normal effect. So because of colder water, because of displace of warmer water here, colder water will rise upward. Water will rise upward. So there will be mixing of water, where there will more the ocean will become more nutrient rich, and that is very favorable for fishing. So this region become high pressure, this region become low pressure. So air will rise here, gradually move, then again they fall here. So it produces circulation like this, which is called Walker circulation. This is during normal condition, where there will be rainfall here. But this condition reverses when these trade wind become weaker. Why? Because these trade wind that drive the ocean current or displaces the water along the equator to this region. If this wind weakens, then the water cannot displace from here. If water cannot displace from here, then water upwelling will not occur. Water upwelling will not occur. So that condition is called as your El Nino condition. where you can see here the trade wind will become weaker, then water cannot displace, so there will be strong counter current will start to flow from this region to this region, and this Peruvian region will become warmer, which will ultimately become the low pressure region, and this will become the high pressure region. So this effect is called as your El Nino effect, where there will be warmer condition here and there will be no upwelling there. Then during La Nina condition, this region, like in normal, this will be high. It will be more colder. It will be more colder. There will be more stronger trade winds. It will be more colder, and there will be more upwelling and mixing. So it will be more nutrient rich in La Nina condition, where this region will become more colder than the normal condition. So these are your circulation. It is called as your ENSO, El Nino Southern Oscillation. Because of this total phenomenon, these regions become nutrient rich or deficient in nutrient, which affects the coastal region. Another same pattern occur in Indian Ocean, between the east and west part of the Indian Ocean. That is called as your IOD. That is called as your IOD, where there is your Australian region or Indonesian region and African region. So there are two types of IOD. IOD means Indian Ocean Dipole. IOD, Indian Ocean Dipole. So the IOD, there are two phases of IOD, like we have in ENSO, we have El Nino, La Nina. Here we have negative and positive dipole moment. During positive dipole moment, there will be colder or high pressure in the Australian region and low pressure or warmer condition in African region, and that reverses during negative condition. This also drives by trade winds and equatorial current. So these phenomena occur in Indian Ocean. Remember, this affects the monsoon. This affects the monsoonal condition. Here you can see when warm air will rise and they produce a circulation here, where you will get rainfall here. If there will be negative dipole mode, there will be less rainfall during monsoon. Next comes to a helpful ozone layer is found which level of the atmosphere? It is in stratosphere, that we have discussed in physical geology PYQ. So stratosphere contains the ozone layer. Then thermohaline circulation in the ocean generally does not directly depend upon. Thermohaline circulation, it is the displacement of current or ocean current driven by density. So density, the density difference occur because of the salinity or temperature. So that's why thermohaline circulation occur because of density, salinity and temperature, not magnetic field. So which generally does not depend upon magnetic field. That doesn't depend upon the magnetic field. Come to the next question, where we have two statements. One is biosphere does not include the living beings that lie hidden well out of sight. So let's remember, biosphere, it includes all the living organisms that are present on the earth, whether they hidden or they're microscopic, like microbes in soil or in deep oceans, in rocks. They all will be included within the biosphere. So the biosphere includes all living organisms on the earth. So this statement will be incorrect. Then single-celled photosynthetic organism thriving in the sunlight zone of the ocean generate about 80% of the atmospheric oxygen. So single-celled photosynthetic organism is your phytoplankton. So that live in the photic zone of the ocean, upper layer of the ocean, you can say. They produce oxygen by photosynthesis. So they contribute the major. Often you can take the ratio, take the percentage between 50 to 80% of the atmospheric oxygen of the world. They are provided by phytoplankton. So this statement is true. So that means we have statement 1 is false and statement 2 is true. The option D will be correct. So next question, which of the following statements is not true about carbon dioxide? So carbon dioxide is a greenhouse gas present within the atmosphere that helps to increase the temperature of the earth or atmosphere. It is one of the greenhouse gases, so it is correct. The loss of CO2 by photosynthesis might have been produced the first known ice age between 2.2 to 2.4 billion years. So between 2.2 to 2.4 billion year ago, there is an organism existed that is called as cyanobacteria. Called cyanobacteria. So cyanobacteria, it react with do oxygenated or oxygenic photosynthesis. Oxygenic photosynthesis, that means it uses the carbon dioxide. It uses the carbon dioxide to produce oxygen. So during this time period, because of this uh, photosynthesis by cyanobacteria, most of the carbon dioxide from the atmosphere they depleted. As carbon dioxide, it is present within the atmosphere that helps to trap the heat. Because of decrease in carbon dioxide percentage, the temperature or global temperature gradually start to decrease. So that produced the first ice age, which is called as a Huronian ice age, that is between 2.4 to 2.1 gigayear, which occur because of oxygenic photosynthesis by cyanobacteria, which reduce the atmospheric carbon dioxide, and because of this, that releases oxygen, which increase the oxygen, which because of that temperature decrease. So that means loss of CO2 photosynthesis might have been produced fast. It is the correct option. Then the glaciation of late Ordovician. During late Ordovician, that is approximately 444 million year we can take. In that time period, there will be a glaciation. So it is asked is not have been influenced by the reduction of atmospheric CO2. Due to enhanced silicate weathering, that means the silicate mineral they react with carbon dioxide to produce calcium carbonate. So that uses the atmospheric carbon. So during Ordovician period, there are also vigorous mountain building process, and because of the mountain, there will be more erosion. When there will be more erosion, during chemical erosion, the carbon can be used due to in chemical, or you can say in carbonation process. So during late Ordovician time, because of high silicate weathering, the carbon percentage within the atmosphere decreases. That causes the late Ordovician glaciation. So that means CO2 reduction influenced the late Ordovician glaciation. So it will be incorrect. That is not. It is given ki not have been influenced, but it is influenced. Then formation of massive deposit like coal lead to cooling of the climate. So massive deposit coal. We'll take the example of your carboniferous coal, like during Gondwana coal, there is massive coal deposition. So coal are produced in a swampy environment where there will be quick burial. So the plant material they contain carbon dioxide, but if they will be quickly buried, then they will not decompose. If they will not decompose, that means the carbon dioxide present within the plant, they are sealed away in the deep. You can say they sealed away within the subsurface of the earth. So because of massive your deposition, or you can say massive burial of the forest during carboniferous time, though carbon dioxide they cannot release to the atmosphere, so that also decrease the carbon dioxide percentage within the atmosphere, that can cause your cooling of the climate. So remember, if there is more rapid burial, then there will be no decomposition. If there will be no decomposition, then the carbon dioxide that is used by the plant, they cannot return back to the atmosphere. So the answer will be C. So it is incorrect about carbon dioxide. So first, let's review another time. It is one of the greenhouse gases. It is correct. Loss of CO2 photosynthesis. It is that is your cyanobacteria. It is also related with great oxygen wind, where there will the cyanobacteria will do photosynthesis, and that increase greater amount of oxygen within the atmosphere, and that decreases the CO2 and produce an ice age, that is called as the Huronian ice age between 2.2 to 2.4 billion year. And here during Ordovician, it is obviously affected by the reduction of CO2, which is occurred by silicate weathering, and massive deposit of coal, because coal deposition occur without decomposition. That's why they trap the carbon dioxide within the earth, and the carbon dioxide percentage within the atmosphere will decrease. That produce a cooler climate. That means anything that reduce carbon dioxide on the from the atmosphere, that produce a reverse greenhouse effect, where the heat cannot be trapped, because this is the gas that trap the heat within the atmosphere and increase the temperature, or warm, it will produce a warmer climate. But the absence of carbon dioxide will produce a colder climate. So while climbing up valleys occupied by glaciers, one has to climb up against the wind. What are these winds are called? The two local wind you'll find. One is your anabatic wind, another is your katabatic wind. So one is your anabatic, which is, you can say, upslope wind. Another is your katabatic, downslope wind, which is called as a mountain wind, that is downslope, and upslope wind, which is called as your valley wind. So during your daytime, the lower part of the atmosphere, they get more heat because of the radiation, fast radiation that received by the earth, that is absorbed. Then again they radiate. So that's why the lower part of the atmosphere get more heat. So this part get warmer easy. This part get warmer in So this part get quickly warmed. So this will produce a low pressure and wind will rise upward. So that will produce a upslope wind, which is called as anabatic. So during night time, these winds, that is the upslope wind get heavier at the night time because of colder climate. Then they move downward. That is called as katabatic wind. So now comes to the question: when climbing off valley occupied by glacier, if upper part is glacier, then upper part is colder, so lower part will be warmer. So the wind will move upward. So that will be considered as your katabatic wind. Then this monsoonal wind, it is a seasonal wind that occur in the Indian Ocean. Then your other wind belts are here. You can see one is trade wind that flow from 30-degree north to 0-degree equator. This is northeast trade wind. This is southeast trade wind. So how this wind belt produce? This is your 0-degree latitude, that is equator. So equator always closer to the sun, so it receive more heat. So when this part receives more heat, then it rises upward. Here wind will rise upward because this part will receive more heat. Then they diverge towards the north and south region. So they gradually diverge in the upper atmosphere. Then they gradually become heavier, cooler. At 30-degree latitude, they again descend. When they will descend, then this region will be a low pressure region. This region will be high pressure region, because here heavy air will descend, here lighter air will move upward. So this will be low pressure, this will be high pressure. Now wind will flow in the ground from high to low. So it should flow like this, but because of the Coriolis effect, they bend like this. So because of the Coriolis effect, it is a deflection of object because of rotation of the earth. So object always deflect right side in the northern hemisphere and left side in the southern hemisphere. Now wind is flowing in this direction, this is the right side, so it will deflect like this. The more the Coriolis effect, the more the deflection will be. So now this is called as your trade wind. This is called as your trade wind. And then from 30 degree to 60 degree you will get western lights, because this is high pressure, then again this is low pressure region, so mostly flow towards the from the west, so that's why it is called as western lights. This is western lights. Then from 30 to 90 we have another belt, that is eastern lights. So these are different wind belts, and these are cell produced, because rise upward, then again descend and they produce a cell. This cell is called Hadley cell, that is 0 to 30 degree, 30 to 90 it is called Ferrel cell, and 30 to 60 it is called Ferrel cell, 60 to 90 it is called polar cell. So remember this, it is very important. So for this question our answer will be katabatic wind. So next question, the two statements state storm surges are generated by low atmospheric pressure and high wind speed. So storm surges, you can take the example of tropical cyclone that occur because of low pressure. When the ocean water warms up to 26 to 27 degree, they produce a low pressure region. Because of the low pressure region, the wind from other part will blow to that region, and they produce a rotating effect because of the Coriolis force. So obviously storm surges are generated by low atmospheric pressure and high wind speed, that is correct. The largest surges occur when wind blows towards coastal embankments. Coastal embankments, you can take the example of bay, where the ocean that intrude into the land region, or ocean narrows down in that region and coincide with the high tides. So large surges occur. First thing, during your storm surges, there is large wave. So when these large wave they enter into the bay region, so they compressed, they compressed, and their height will increase furthermore. And when they added with or coincide with the high tides, then you'll get very large surges. So that means both the statement are correct. Both the statement are correct. Then comes to fauna with free swimming lifestyle. There are different flora and fauna you'll find in ocean. Some is free swimming, some is attached to substratum, some are you can say just flow with the current or drift with the current. Some found in the bottom of the ocean. So neck to neck it is a free swimming fauna. Planktonic, these are not swimmer but they drift with the ocean current. So take the example of phytoplanktons. Then benthic, they occur at the bottom of the ocean. They dwell at the bottom of the ocean. They are called benthic. They may be on the ocean floor, or they may produce hole, or they may burrow within the subter sediments. They are called as benthic. Pelagic, it is not a lifestyle habit, it is a region. So, it is a deep ocean region where you will find you will get finer sediment deposition, that is called as pelagic. Come to the next question. Which of the following is mostly associated with the region of ozone depletion in the atmosphere? So ozone layer, it is found in the stratosphere. So chlorofluorocarbon, it is the main chemical that is responsible for ozone layer depletion. So CFC, generally you can call it as CFC. CFC generally form refrigerators, air conditioners and aerosol sprays. They rise into stratosphere, where ultraviolet ray that breaks them down and that releases chlorine atom. So chlorine atom, it react with ozone to produce ClO and O2. So a single chlorine atom can destroy thousands of ozone molecules. So chlorine reacts with ozone and destroy it. So now it is O2s, it can be used. So that's why chlorofluorocarbon, it is the main chemical that deplete the ozone layer. Come to the next question. Tides in oceans are primarily caused controlled by. So no tides are rhythmical rise and fall of water level in the ocean. They're primarily caused by the gravitational effect of sun and moon. So because of the gravitational force of the moon, you will find bulges in the equatorial region, that is called equatorial bulges. Because of that, the level of the water increases. It is a vertical fall and rise that because of the attraction of the moon. So mostly moon affect more than the sun, because sun maybe is more larger or having more mass, but it is also farther from the earth. That's why moon mainly affects the tidal condition on the earth. So you'll see there will be spring tide, neap tide during different days in months. So mostly moon affects it. This comes to bathymetry refers to. So bathymetry refers to your study of ocean bottom topography or ocean floor. So according to the bathymetry, you can divide the ocean into continental shelf, continental slope, continental rise, then mid oceanic ridge, abyssal plain. They're all the part of the bathymetric studies. So ocean floor and their topographic changes are called as your bathymetry. So remember continental shelf, then slope, then rise, then abyssal plain, then mid-oceanic ridge. So continental shelf, it is up to 200-meter depth. Then there is slope. Then in abyssal plain you will get up to a depth of 5,500 meter. Sorry, 5,000 meter. And in trench region you will get the most or highest depth, that is in marina trench. You will get 10-kilometer depth. Then resident time of water vapor in atmosphere. So what is resident time? So resident time of substance in atmosphere, or it is also you'll study that is resident type of any elements within the ocean. So resident time of substance is the average time it stays within the atmosphere before being removed by any process, by precipitation or by chemical reaction. That is called your resident time. In ocean also we use resident time, where any chemical constituent can remain in dissolved condition for without precipitation. That is its resident time. So resident time of water vapor. So water vapor generally it can remain within the atmosphere up to 10 days. After that it precipitates. Then there are some other. There is methane. It is between 10 to 12 days. Then carbon dioxide 100 or 200 years. Then nitrous oxide is 110 to 120 years. Oxygen it is 4,000 years. Nitrogen it is 10 million years. So these are different resident time. We have to remember. Next, the content of water vapor by volume in the surface air of moist tropical areas is approximately. So you have to remember this thing. This is a data question. So it is up to 2.6 percentage you'll find in tropical region, 2 to 4% you'll find in tropical region, and temperate region it is 1 to 2%, and cold polar region you'll get up to 0. Or less than 0.5%. So in tropical region 2 to 4%, in temperate region 1 to 2%, in cold polar region less than 0.5%. So answer will be 2.6. Then the portion of scattered and diffused solar radiation reaching the Earth's surface is called as. So scattered and diffused solar radiation. So the incoming solar radiation, that is from the sun, that is we call electromagnetic spectrum. When it travels through the atmosphere, it interacts with the particles within the atmosphere like dust particle or other water vapor particle. It will interact with them. So while incoming these particles, they scattered we can say the ray that is coming from the sun, they scattered by these particles. So that is the scattering, the different type of scattering. So the portion of scattered and diffuse solar reaching the earth surface is called, so we will call diffuse blue light, diffuse daylight. How? So suppose this is sun. So ray coming from the sun, so they can diffuse on the atmosphere. Sorry, scattered on the atmosphere like this. So the scattering, you can call them as ray-leak scattering. When ray interact with very small particle, they produce an effect that is called Rayleigh scattering. So as in Rayleigh scattering, generally very smaller wavelength of lights are involved. So smaller wavelength light invisible is your blue light. So blue light is scattered because of the dust particle, and because of that the sky it looks blue. So that's why it diffuse blue light. And when it come to the surface, it also produce a scattering effect that is considered diffuse daylight. So the answer will be A and B. A and B only. So when warm air layer lies over cold air layer in the atmosphere, this phenomenon is called as. So this is called as your inversion of temperature. So sometimes there is in you can say clear sky or in clear weather condition, there will be no significant amount of mixing of air. So that's why you'll find layer of colder air and warmer air. So this phenomenon is called as your inversion of temperature. Then come to subpolar low pressure belts. So we have discussed this in a previous question. So equatorial is the low pressure zone. This is called as your doldrums, where both the trade wind will converge here. This is also called as your intertropical convergence zone. This is low pressure, this is high pressure, this is horse latitude. Then again this is low pressure, then this is high pressure. So low pressure, high, low, high. So subpolar low pressure, it is between 55 to 60 degree. It is between 55 to 60 degree, both north and south. So which among the following is not a tropical cyclone? We have already discussed tornado, typhoon, hurricane, they all are tropical cyclone. Only squall, it is locally wind surge. Suddenly the wind velocity increases during thunderstorm. So it is not a tropical cyclone. A volcanic island that erodes and sinks beneath the sea level. This also we have discussed in physical geology question. We have sea mount, goets, and island. They all occur during intraplate volcanism. So when intraplate volcanism occur, then a mountain will produce, or an island will produce, or volcanic mountain will produce. If it will emerge above the surface, this is called as your sea mount. This is called as your island. If does not, it cannot grow to the sea level, then it is called as a sea mount. If island erodes, it produces a flat top. This is called as your goets. Suppose this is, you will take water level. This is sea level. So this will be island. This will be sea mount. This will be goet. Then submarine vent, it occur near hydrothermal deposition at mid-ocean degrees. You'll get black smoke or white smoker type of deposition. This thing you'll study in MSc in your BMS type of deposition, volcanogenic massive sulfide deposition. Then reef, these are called coral reef that occur because of coral deposition along the slope of the mountain. So these are three types of coral reef: fringing reef, barrier reef, atoll. So fringing reef, the most common type of reef that generally grows attached to the shoreline in coast of islands. Then barrier reef, similar to fringing reefs but separated from the coastline by deeper wide lagoon. So they are separated from the coast, and atolls are circular, where the you can say the mountain or the island is completely submerged. So this is the evolution, you can say. First, this mountain is gradually submerging, and coral reefs are reducing, because when mountain will submerge, the depth will increase, ocean depth will increase, then coral reef cannot sustain below the depth of 200 meter. So this is all about your atmospheric science question. So in the next video we'll cover some other topic. So please like, subscribe, and give comment about the video. Thank you.